Geometric series is a series or a sequence which each term after the first one obtained by multiplying the preceding term by a fixed constant non-zero. For example, if I start with 7 and I multiply 7 by 2, give me 14, multiply by 2, give me 28, and so on. So I start the sequence with 7, but each time I multiply the sequence by 2. So here I multiply each preceding term by 2. Or if I start with 100 and then I multiply it by half, which is the same as divided by 2, give me 50, multiply by half, give me 25, and so on. So a geometric sequence, it's a sequence where I'm multiplying by a constant value, non-zero each time. This value, the number that we multiply with, we called it a common ratio. Let's start with the example number 1. Writing a term in a geometric sequence. Write the first 6 terms of the geometric sequence whose first term is equal to 12, and don't forget that we call the first term as A1, and the common ratio here is equal to 1 over 2. So I start with 12. 12 multiplied by half 6, multiplied by half 3, multiplied by half 3 over 2, multiplied by half 3 over 4, 3 over 8, and so on. And we prefer to write the answer as a fraction. Exercise 10.3 from your book, asking about writing the first 5 terms of the given geometric sequence. Regarding number 1, the first term is 5 and the common ratio is 3. So I'm going to write 5, and each consecutive term I'm going to multiply by 3. So 5, 15, 45, and 45 by 3 is 135. Multiply 3 is 404. Sorry, 405. The second one, first term is 20, and every time I multiply by half. So 20, 10, 5, 5 over 2, and 5 over 4. For number 5, I have the recursive formula -4 multiply the preceding term. So if I want to find the first term, it's a given already. 10, and then each time I'm going to multiply by -4. So -40 multiplied by -4 is 160, multiplied by -4 is -640, multiplied by -4 is 2560. Notice that in the geometric sequence, you can figure out a sequence that the first term is positive and the next term is negative, then positive, negative, or the first term is positive and the next term is negative. But you can't find the same in the arithmetic sequence. General term of a geometric sequence. I'm using the general term to define a rule for the geometric sequence. As we can see, an, the particular term I'm looking for, is equal a1, and the a1 is the first term, and r is the common ratio. For example, how I can use the formula for the general term to figure out the 7th term of a geometric sequence whose first term, a1, is equal to 5 and its common ratio is equal to -3. So an is equal a1 r to the power of n minus 1. So a7 is equal a1, 5 multiply r to the power of 7 minus 1. So it's 5 multiply -3 to the power of 6. So 5 multiply -3 to the power of 6 is equal to 3645. Another exercise, 10.3. Find A8. I wanted to find the 8th term of an geometric sequence whose first term is 6 and r is equal to 2. don't forget that the general term is equal to A1 R to the power of n minus 1. So if I wanted to find A8, directly I can write it as A1 R to the power of 7. So it's equal to 6 multiply 2 to the power of 7. So 6 multiply 2 to the power of 7 is equal to 768. What if I wanted to solve question 13 and I wanted to find A40? A40 is A1 R to the power of 39. So it's 1000 multiply R, which is negative half, to the power of 39. So it's equal to 1000 multiplied by negative half to the power of 39. And the answer is negative 1.2 multiplied by 10 to the power of negative 9 to the nearest one decimal place. Write the general term for the geometric sequence 3, 6, 12, 24, and 48. Then use the formula to find the 8th term. The general term is an is equal a1 r to the power of n minus 1 for the geometric sequence. So we can define a1 as 3, and to find the common ratio, all what you have to do is to divide the second term by the first. So 6 divided by 3 is equal to 2. So r, which is the common ratio, is equal to 2. So an is equal a1 multiply r to the power of n minus 1. What if I wanted to find the 8th term? So a8 is equal 3 multiplied by 2 to the power of 8 minus 1. So it's 3 multiplied 2 to the power of 7. And 3 multiplied 2 to the power of 7 is equal to 384. From the exercise of 10.3 in the book, for question 17 and 19, I wanted to figure out the formula for the general term, which is the nth term of the geometric sequence, and use this formula to find A7. So for question number 17, A1 is equal to 3, and the common ratio is 12 divided by 3, which is equal to 4. An is equal A1 r power n minus 1. So the general term is A1, 3 multiply 4 power n minus 1. What if I wanted to find the 7th term? It's 3 multiplied by 4 to the power of 7 minus 1. So it's 3 multiplied by 4 to the power of 6, which is equal to 12,288. Regarding question number 19, the first term is equal to 18, and the common ratio is 6 divided by 18 equal 1 over 3. So if I want to find the general rule, an, it's a1 r power n minus 1. So an is equal a1, 18 multiply r, which is 1 over 3, to the power of n minus 1, and n minus 1 in terms of n. I wanted to find the 7th term, so it's 18 multiply 1 over 3 to the power of 7 minus 1. So it's 18 multiply 1 over 3 to the power of 6. By using my calculator, it's 2 divided 81. Find the sum of the first n terms of a geometric sequence. The sum Sn of the first n terms of a geometric sequence is given by Sn is equal a1, the first term, multiply 1 minus r, common ratio to the power of n, divided 1 minus r, where is r is the common ratio. For example, to finding the sum of the first n term, find the sum of the first 9 terms. So I wanted to figure out S9. So A1 1 minus r to the power of 9 over 1 minus r. So first, let's define what is the first term, and it's clear for us that it's equal to 2. And to define the common ratio, I need to divide negative 6 by 2. So it's negative 6 divided by 2, which is equal to negative 3. So S9 is equal. I prefer if you can write a bracket. So A1, which is equal to 2, 1 minus R is negative 3 to the power of 9 divided 1 minus negative 3. By using my calculator, it's 2 multiply 1 minus negative 3 to the power of 9 divided by 1 minus negative 3 is equal to 9,842. Question number 25, use the formula to find the sum of the first n term. This exercise 10.3 in your book. Find the sum of the first 12 terms. So I want to find S12 of geometric sequence, and the rule for the geometric sequence is Sn is equal A1 1 minus r power n over 1 minus r, where is r the common ratio. So the first term is equal to 2, common ratio is 6 divided by 2, which is equal to 3. So the sum of the first 12 terms is equal to 2 multiply 1 minus 3 to the power of 12 divided 1 minus 3. By using my calculator, it's 2, 1 minus 3 to the power of 12 divided by 1 minus 3. It gave me 531,440. Question number 30. Find the sum of the first 14 terms. So I want to find S14 for a geometric sequence. So Sn for the geometric sequence is A1 1 minus r power n over 1 minus r. So I need to figure out what is the first term, and it's clearly negative 1 over 24. To find the common ratio, all what I have to do is to divide the second term by the first term. And 1 over 12 divided negative 1 over 24, it gave me negative 1 over 12 divided by negative 1 over 24 give me negative 2. So I wanted to find the sum of the first 14 terms of A1, negative 1 divided by 24 over 1 minus negative 2 to the power of 14 over 1 minus negative 2. So S14 is equal to 5,461 divided by 24. And I prefer to keep your answer as a fraction. Find the following sum. And as we know, this sigma, this symbol called sigma, and it's for using for summation. Find the sum of the first 8 terms from the first term for this sequence. Since you have I in the power, it's an exponential or geometric sequence. I prefer if you can find the first and the second and the third term to decide and define if it's an arithmetic sequence or geometric. So it's 2 multiplied by 3 to the power of 1, which is equal 6. Then 2 multiply 3 to the power of 2. I'm replacing I with 2, which is equal to 18. Then 2 multiply 3 to the power of 3, which is equal to 54. So it's clear for us that the first term is equal to 6, and it's an geometric sequence every time you are multiplying by 4, so the common ratio is equal to 3. So Sn for the geometric sequence is equal to it's equal to A1 multiply 1 minus r to the power of n over 1 minus r. So I want to find the sum of 8 terms. For A1, which is 6, 1 minus r, which is 3 to the power of 8 over 1 minus 3. So 1, by using my calculator, 6, 1 minus 3 to the power of 8 divided by 1 minus 3. So it's equal to 19,680. Find the sum of an infinite geometric sequence. And I can find the sum, which we called it S infinity, for a geometric sequence if the common ratio is between 0 and 1 as a positive absolute value, or between -1 and 1 as a value. For example, if you have a sequence that the first term is 100 and every time you multiply by half, so every time you divide by 2 or multiply by half, here in this case it's moving down to reach 0 after a specific number of terms. Here you can find S infinity. But if the common ratio is greater than 1 or even equal to 1, you cannot find S infinity. So S infinity is for the geometric rules, which its common ratio lies between -1 and 1, or the series or the sequence is going down, is decreasing. Okay, and we can figure it out by using the rule S infinity is equal A1 divided by 1 minus R. First example to define the sum to infinity for a geometric sequence, which is A1 over 1 minus R for this series. And the difference between series and sequence, series you have the sign plus or minus between each two consecutive terms. But in a sequence, I'm going to write it as 3, 2, 4 over 3, 8 over 9, and so on. This is the difference between sequence and series. So it's clear for us that the first term is equal to 3, and the common ratio is 2 divided by 3, as I'm dividing 2 by 3. So this value is smaller than 1 and greater than 0, so I can find S infinity, which is A1, 3 over 1 minus R, which is 1 over 2 over 3. So it's a 3 divided 1 over 3. Without using calculator, it's a 3 by 3, which is equal to 9. Example to find the sum of infinity, the summation method. Here, infinity. So I am sure that I wanted to find S infinity. And S infinity for the geometric sequence is A1 over 1 minus R. But let's first find the first term. So it's 12 multiply -0.7 over 1 minus 1. So it's equal to 12. And to figure out the second term, it's 12 multiply -0.7 over 2 minus 1, which is equal to 12 multiply -0.7. It's equal to -8.4. So it's moving down or decreasing, and the common ratio in this case is -0.7 after I divided -8.4 by 12. So S infinity is the first term over 1 minus -0.7. So S infinity is 12 divided by 1 minus -0.7, which is equal to 120 over 17. Question number 10, I think, or 11. how we can express a recurring decimal into a fraction in its lowest term by using S infinity. What? 0.7 recurring? 0.7 recurring, Mr. Hisham, is 0.77777. But I can write it as 0.7 plus 0.07 plus 0.007 and so on. So I can rewrite it as 7 over 10 plus 7 over 100 plus 7 over 1000 and so on. So it can be written as a sequence. Its first term is 7 over 10 and its common ratio is the second term divided by the first, so 7 over 100 divided 7 over 10, which is equal 1 over 10. So it's form a geometric sequence. Its first term is 7 over 10 and its common ratio is 1 over 10. So what if I wanted to find S infinity? It's A1 over 1 minus R. So A1 is 7 over 10 over 1 minus 1 over 10. So it's equal to 7 over 10 divided by 9 over 10, which is equal to 7 over 9. So 0.7 recurring can be written as a fraction equal to 7 over 9 by using the properties of the geometric sequence and the properties of the sum to infinity of the geometric sequence.